Today I will present the article called Application for Challenge-Based Learning Methodology as a Trigger for Motivation in Learning in Robotics. Table of contents: 1. Introduction. 2. Objective. 3. Methodology. 4. Result. 5. Conclusion and future work. 1. Introduction. The development of robots required an understanding of mathematical, physics, electronic, and computational concepts. The main problem that students face is low motivation, low learning, and abandonment of the project by not understanding the concept of kinematics because it is not perceived as something tangible or applicable. Higher education must have renewed vision for its planning. It must be congruent with today's society, such as development of new technologies, which currently expand borders and transfiguring the teaching learning process. This methodology seeks to increase the motivation to learn, develop skills and abilities for a deep understanding of kinematics, and develop their abilities to diagnose and solve problems and propose solutions. Currently, many companies that appear in the robotic area use CVL for the development of projects, which is another important factor to take into account in the education. We must prepare students for working life. The objective of the study is to evaluate learning and motivation in students through the test and post-test exam. 3. Methodology. Challenge-based learning is a didactic resource for the design of experiments and activities that add value to classes, connect the students with their experience, brings them closer to the real world, and makes them contribute to their community by finding solutions to problems real. This paper presents a modification for the CVL methodology applied to a group of 10 students from the Robotic System Laboratory 0 on the Faculty of Computer Science, FCC. The CVL modification integrates elements of inquired learning and it's also interdisciplinary and also creates an active learning environment. The students are actively involved in asking questions, solving the problem, and most creative throughout the experience. They are intellectually, creatively, emotionally, socially, and physically involved. His relationship with other students, with himself, and with the world are developed through the entire experience. The teacher is one who raises a topic that arose interesting and that affects the student's environment. To solve the challenge, question the student about his previous knowledge. In addition, it guides the solution, proposes question, their viability and relevance, moderates the implementation of the solution, and propose mentored instrumental. Finally, it facilitates the publication of evidence in different media, web, school, and community. 4. Results. Results were obtained by applying the post-test and the pre-test exam, where the pre-test exam is identical to the post-test exam because it is required to make a comparison between before and after the application of CBL modification. Both the tests are based on the Likert type survey of or design, where the answers were much, little, and nothing. Question 1 to 5 of the pre-test and post-test exam have the objective of the measuring prior knowledge, and those same questions in the post-test measure to learning acquired later. Question 6 to 10 of the pretest measure the motivation prior to the application of CBL methodology, and those of the post-test the motivation acquired later. In this table, 1 to 5 show later knowledge. Row 1 show that 80% of the students know a lot about how to move a robotic arm. In row 2, 70% of the students know the parts that make up a robotic arm. In the third row, 60% of the students know little about the mathematics that goes into the design. 6 to the 10 show later motivation. In row 6, show that 80% of the students feel motivated to design a robotic arm. Conclusions in future works. CBL is an active methodology highly recommended to apply in small groups of the students. We are proposed to continue implementing CBL with a small group within laboratory to motivate and teach the members seeking to improve the application progress. It was observed that the students developed competences and skill for deep understanding of robotics and developed their abilities to diagnose and solve problems. With the data obtained has been shown that the CBL modification can be applied in the context of the academic environment of the student, in this specific case in the zero laboratory. Finally, here are the contact details of all participate in this work. Thank you.